Okay, so we're going to go ahead and get started talking about second derivatives. So establishing what a second derivative is. Um, it is going to be the derivative of the derivative. So we have a couple different ways to notate this. It could be written as f double prime of x. That's a second derivative, or d2y over dx squared. So both of those are ways to write the second derivative. But again, a way to think of it is the derivative of the derivative. So that's another way to think of it. So for example, if I have the function f of x equals x cubed plus 3x squared plus 12x, then the first derivative, y'all know how to take, is 3x squared plus 6x plus 12. And then our second derivative would just be taking the derivative one more time, and that would give us 6x plus 6. So the second derivative is pretty straightforward and pretty easy to do. So you might recall that a first derivative tells you about slope. The second derivative tells you about concavity. So concavity is about whether it's facing concave up or concave down at a certain point. So the second derivative test for extrema, again, from your first derivative notes, you might remember that when f prime of x, so when the first derivative equals 0, that means there is a max or a minimum. But we can't really tell which one it is unless you want to plug in values on each side, or now using the second derivative test, you can plug that value in to the second derivative. If it is negative, then that means it is concave down, which means that point has a maximum. If it is positive, that means the function is concave up at that point, and it has a minimum. And we'll go through this lots more, especially in the next unit, but this is just a small introduction about how to classify maximums or minimums. You can use the second derivative to say which one is which. Okay, as far as evaluation, you just need to plug in a value. So let's say we have f prime of 3, f double prime of 3. If our function f of x is 3x to the 4th, we'll just make it simple, then f prime of x is 12x cubed, and f double prime of x is 36x squared. And then we would just plug in 3, just like in regular old algebra 1. So you would have 36 times 9, which is 364. And that would be your final answer. I think it's 364. So then your next thing on the notes is a point of inflection. Now, some of you might remember that a point of inflection is a point where the concavity changes. And if it's a point where the concavity changes, then that is the same thing as the second derivative being equal to 0. So if I ask you to find the points of inflection of any given function, you would take the second derivative and set it equal to 0. Lastly, we have the intervals. So this is referring to if I asked, where is this function concave up? Then you would look for all of the places where the second derivative is greater than 0. where it's positive. If I asked for concave down, you would find the intervals, the x values, where the second derivative is less than 0. And that's it. So that's your notes for second derivatives.